Heat energy. Objectives. Describe what is energy. Define specific heat capacity. Calculate specific heat capacity, heat, mass, or change in temperature of a sample of matter. And finally, calculate heat of fusion and vaporization of a sample. What is energy? Energy is the ability to do work. Energy can be classified as kinetic or potential. Kinetic energy is the energy of motion, while potential energy is determined by the position of an object or by the chemical composition of a substance. For example, a ball at the top of a hill has potential energy. The potential energy can be transferred into kinetic energy as it rolls down the hill. Or the bonds in a molecule of propane has potential energy. When it combusts and burns, it's converted into heat energy. What are some forms of energy? Energy can exist in forms such as chemical, electrical, electromagnetic, thermal or heat energy, mechanical, and nuclear. Heat is associated with the motion of particles. It is always transferred from a higher temperature to a lower temperature. For example, a block at 80 degrees Celsius next to a block at 20 degrees Celsius. Heat energy will flow from the high temperature 80 degrees Celsius to the low temperature 20 degrees Celsius. Practice question. Which form of energy is transferred when an ice cube at 0 degrees Celsius is placed in a beaker of water at 50 degrees Celsius? Here we have a temperature difference. Therefore, heat energy will be transferred. Our answer is thermal, choice 4. Practice question. A beaker with water and its surrounding are all at 24 degrees Celsius. After ice cubes are placed in the water, heat is transferred from. The ice cubes are at 0 degrees Celsius. Therefore, heat energy from the water and the surroundings will transfer into the ice cube. The answer choice here is choice 3, the water to the ice cubes. What is the unit of energy? The SI unit of energy and work is the joule. 1000 joules is equal to 1 kilojoule. For example, which quantity of heat is equal to 1400 joules? Here, we can set up the equality 1000 joule is equal to 1 kilojoule and have two conversion factors. Using what is given, 1400 joules, we can select the conversion factor to cancel joules. Here, 1 kilojoule over 1000 joules. The joules cancel out. And we have 1.400 kilojoules. Practice question. Which quantity of heat is equal to 200 joules? Here, we have the same equality. 1000 joule is equal to 1 kilojoule. We have two conversion factors. Substituting their given and using a conversion factor to cancel joules, we have our final answer as 0.200 kilojoules. What is specific heat capacity? Every substance has its own characteristic ability to absorb heat. Certain substances require more heat than others to reach a certain temperature. For example, the water in the ocean might need more heat than the sand to get warm. The energy requirement for different substances are described in terms of a physical property called specific heat capacity. The specific heat capacity for a substance is defined as the amount of heat required to increase the temperature of 1 gram of a substance by 1 degree Kelvin or degree Celsius. How can we calculate specific heat capacity? Using the formula, C as a specific heat capacity is equal to heat divided by mass times the change in temperature in Kelvin or degrees Celsius. For example, calculate the specific heat capacity in joules per gram degrees Celsius of iron if 183.6 joules raises the temperature of 32.5 grams of iron by 12.5 degrees Celsius. First step is to identify our given. C is unknown, the specific heat capacity. Q, the heat, is 183.5 joules. M, the mass, is 32.5 grams. delta T, the change in temperature, is 12.5 degrees Celsius. Substituting into our formula, we have the specific heat capacity as 0.452 joules per gram degree Celsius. Heat calculation from specific heat capacity. We can use the formula given in reference table T, Q is equal to mc delta T, to find the different variables. For example, heat is equal to the mass times the specific heat capacity times the delta T, or the temperature change. Mass can be obtained by dividing both sides by the specific heat capacity and delta T, and we have M is equal to Q divided by C delta T. The specific heat capacity, rearranging the formula, we have C is equal to Q divided by M multiplied by delta T. While temperature change, if we divide both sides by mass and specific heat capacity, we have delta T is equal to Q divided by M times specific heat capacity. Expanding the delta T, we have the final temperature minus by the initial temperature is equal to Q divided by M times C. How can we calculate heat from specific heat capacity? Rearranging our equation, we have Q is equal to mc delta T. For example, determine the amount of heat absorbed by 45.2 grams of aluminum if its temperature increases from 12.5 degrees Celsius to 76.8 degrees Celsius, if the specific heat capacity of aluminum is 0.897 joules per gram degree Celsius. Here we have our given. The final temperature is 64.3 degrees Celsius. Substituting into our formula, we have the heat as 2,607 joules. Practice question. What is the amount of heat absorbed when the temperature of 75 grams of water increases from 20 degrees Celsius to 35 degrees Celsius? Here we use the heat formula, Q is equal to mc delta T. We need to identify the specific heat capacity for water. Using reference table B, we are given the specific heat capacity of water as 4.18 joules per gram degrees Kelvin. We can substitute degrees Kelvin with degrees Celsius because a 15 degree change in Celsius is equivalent to a 15 degrees change in Kelvin. Substituting in our formula, we have the heat as 4,700 joules. How can you calculate mass from specific heat capacity? We rearrange our formula, have M is equal to Q divided by C times delta T. For example, the temperature of a sample of silver increases 17 degrees Celsius when it absorbs 40 joules of heat. Determine the mass of the sample if the specific heat capacity of silver is 0.235 joules per gram degree Celsius. Here we have our given. We substitute it into our mass formula, and we have our final mass as 10 grams. Practice. The temperature of a sample of water changes from 10 degrees Celsius to 20 degrees Celsius when the sample absorbs 418 joules of heat. What is the mass of the sample? We have the given, Q is equal to 418 joules, mass is unknown, the specific heat capacity is obtained from reference table B, the temperature change is 10 degrees Celsius. Substituting into our formula, where mass is equal to the heat divided by the specific heat capacity times delta T. Our final answer is 10 grams. How can we calculate temperature from specific heat capacity? Using our equation and rearranging, we have T2 minus T1 is equal to Q divided by M times C. Example 1. An 18-gram sample of water has an initial temperature of 22 degrees Celsius. After the sample absorbs 600 joules of heat energy, calculate the final temperature of the sample. Here the given, Q is the heat, 600 joules, mass is 18 grams, the specific heat capacity of water is 4.118 joules per gram degree Celsius, and the temperature change is T2 minus the initial temperature, 22 degrees Celsius. Substituting into our formula, we have the final temperature as 30 degrees Celsius. Practice. A 100-gram sample of water at 22 degrees Celsius absorbs 8,360 joules of heat. what will be the final temperature of the water? Here we identify the given. Substituting into our formula, we have our final temperature as 42.0 degrees Celsius. What is heat of fusion? During melting, the heat of fusion is the energy needed to convert 1 gram of solid to liquid. For example, 334 joules of heat is needed to melt exactly 1 gram of ice at its melting point, 0 degrees Celsius. The heat of fusion is also the quantity of heat that must be removed to convert 1 gram of liquid to a solid. For example, 334 joules of heat must be removed to freeze 1 gram of water at its freezing point. The heat of fusion for a substance can be used to calculate the heat absorbed or released. Q is equal to mHf, where Q is the heat, m is the mass, and hf is the heat of fusion. For example, determine the heat required to melt 26.0 grams of ice at its melting point. Using reference table B, the heat of fusion is given as 334 joules per gram. Plugging in our given into our formula, we have 8,684 joules at its melting point. What is heat of vaporization? The heat of vaporization is the energy required to convert 1 gram of liquid to gas at its boiling point. For example, 2,260 joules is needed to convert 1 gram of water to vapor at its boiling point, 100 degrees Celsius. The heat of fusion is also the heat released when 1 gram of vapor changes into liquid at its boiling point. Using the formula, Q is equal to mHv, where Q is the heat, m is the mass, and Hv is the heat of vaporization. Example 1. Calculate the heat required to vaporize 42 grams of water at 100 degrees Celsius. Using reference table B for the heat of vaporization of water, 2,260 joules per gram. We have the given, we plug in our formula, Q is equal to mHv, and the heat required is 94,920 joules. When we see the term vaporize, we know right away we must use heat of vaporization formula.